called the RFC 1918 range. I'm going to pass over a lot of these things. I'm not going to go into too much detail, but these are all available to look on the internet. The RFC 1918 range doesn't exist anywhere on the internet. It's a private IP range, which means that if you use it in your VPC, you're not going to conflict with anything on the internet. And that's quite important, because if you conflict with something on the internet, you can't talk to that thing. Now, conflicting is also important on-premise. So if you're connecting onto on-premise, you're connecting to other VPCs within AWS, then you need to not be using the same address everywhere. You need to be using a different set of CIDR ranges for each VPC so that you don't overlap. And that's going to be quite important because overlapping addresses can't talk to each other easily. So just to touch on that /16, that /16 really means 65,000 odd addresses. That's a great place to start. Lots of space for you to expand and grow what you're running in AWS. But if you run within a business that has a networking department, it's quite normal that they may ask you to use a smaller range. So when choosing the range, when choosing the size of the network, have a think about how big, how many systems you're going to run in that environment, and choose the subnet accordingly. So that was a CIDR range. That's a range of addresses you're going to use inside the network. But what do you do with those? Well, let's start again with that VPC, that virtual data center, as I talked about it, in the cloud. That has the CIDR range, and we want to break that up into availability zones. Now, an availability zone, in this case, I've highlighted Dublin's 3 availability zones. Availability zones are separate risk domains. Each of them are one or more data centers. Those data centers are on different power grids. They have different flood profiles. We do this so that if something were to affect an availability zone, it wouldn't affect multiple availability zones. That's really good for resilience. But in those availability zones, you need to put subnets so that you can talk one to another. The subnets, in this case, are subdivisions of that CIDR range. In this case, 172.31.0.1 and .2 dot something /24. In this case, I'm using the first 3 numbers of the IP address to denote the actual network, and I'm using the last number to denote the machine. And in this case, each subnet can contain about 250 addresses. Now, I mentioned all of these IP things, and these are all IPv4. I'm going to brush fairly quickly over IPv6, but basically, we're running out of addresses. So IPv6 came along, which has many more addresses. It comes from a group big enough for everyone to have a unique address. But those addresses don't exist on their own. In AWS, we run something called a dual stack, which means those addresses are overlaid on top of the same instances that your IPv4 addresses are. So if you start to use IPv6, every network and every instance will have both an IPv4 and an IPv6 address. Great, so that's a lot about addressing, but now we're going to talk about talking between addresses. None of this is about security yet, that will come later. To talk between addresses, we need to be able to route. And a routing, or a route table, is a set of rules that tells us how to move packets around, where to put the next packet. Now, every default VPC has a default route table, and that default route table simply says, everything in my CIDR range is inside my VPC. But you can assign different route tables to different subnets, and we're going to look at how to do that in a minute. But before we do that, let's just have a look at where you configure route tables. On VPCs, you go to the route table tab, and you hit, my clicker is not working, you hit the route table tab, and you will get a routes table. And as it shows up there, 172.31.0.0/16 is local. That means anything in my CIDR range and any of the AZs will talk to one another. But what about the internet? We said right at the beginning of this that it's really useful to talk to the internet. So the easiest way to work through this is to do some examples. We start with your virtual data center, your VPC, and the internet. Now, there are 3 things that you need in order to communicate with the internet. You need to have some form of connection to the internet, you need to have a route to the internet, and you need to have a public address. And if you recall, I said that 172.31 was a private address. It doesn't exist on the internet.